Okay, all good? Perfect. Okay, so most of the problems we're going to do in this lesson are going to be either double angle or triple angle problems, or half angle, or angles that are divided by something that we're going to see. That's the difference between what was in the last section and this section. All right, so we're going to start with some double angle problems. We do have double angle identities, but they're not super useful when we're solving, so we're going to kind of stay away from those whenever we don't have to use an identity. That's always nicer. So instead, we're going to start with a trick that we used in the last section, where if you have an angle that's anything other than just like an x or a theta, we're going to replace it with an easier angle first and solve for that, and then substitute back in later. Okay, so like this 2x, I'm going to just replace 2x with theta. Okay, and I'm going to solve this equation. Sine theta equals a half. Okay, then find those on my unit circle. So where does sine equal a half? 5 pi over 6. Good. Okay. And no matter what the instructions say on these problems, always we are going to put plus the period times k next to these, and you'll see why in a minute. Okay. So plus the period of sine is 2 pi k, plus 2 pi k. Okay. Okay, once I have solved for theta, I can put back in my 2x. So 2x equals pi over 6 plus 2 pi k. 2x equals 5 pi over 6 plus 2 pi k. And then in both of those equations, how do I solve for x? How do I get x alone? Divide by 2, or you could multiply by what? A half. Might be easier just because we already have a fraction there. Okay, so imagine multiplying through a half through this entire equation. I'm going to have x equals pi over 12. If I do 2 pi k times a half or divided by 2, it's just pi k. And then 5 pi over 12 plus pi k. Now, if the problem said find all solutions in radians, period, you're done at this point. If the problem then lists on an interval, in this case it said 0 to 2 pi, we need to figure out what are the answers between 0 and 2 pi. The first answer is pi over 12, and I'll leave a little space. The second answer is 5 pi over 12. Okay, those are both smaller than 2 pi. But there's other answers hidden in here, which is why that plus pi k piece is going to be important. When I divide by 2, I'm shrinking down the period, and we're getting solutions that originally weren't in that first period that are going to be there now because it shrunk down. Okay, so how we figure out the other solutions are we just keep adding on multiples of pi until we get past that 2 pi limit that I have. Okay, so if I have pi over 12 and I add pi, what do you get? 13 pi over 12 is also a solution. If I add pi to that, what do I get? 13 twelfths. I would get 25 over 12. Now 25 over 12 is bigger than 2, right? Because 24 over 12 is 2. So that's how I know to stop. Okay, there's no other answers in this first group that are between 0 and 2 pi. Okay, so if I go to 5 pi over 12, we know that's an answer. If I add pi to that, what do we get? There's 12 twelfths. 5 twelfths and 12 twelfths gives me? Yep, 17 twelfths. If I add 12 twelfths to that, what do I get? 29 twelfths, which is bigger than 2. It's past that limit I have of 0 to 2 pi, so we have 4 answers. Okay, and that's it. Let's practice another one. Cosecant of 2x equals a half. Okay. So I'm going to replace it with a theta, and I'm going to solve the easier equation first. Cosecant theta equals a half. The reciprocal functions aren't directly on our unit circle, so usually we take the reciprocal to find them a little easier. So instead of cosecant, what can I use? Sine is equal to 2. What do we think about that? No solution. Quick and easy. Okay, sign can never equal 2. It only bounces between -1 and 1. No solution. Question so far? Let's try another one. Okay, cosine 3x equals 1/2. Again, I'm going to replace it with a theta. Make my life easier to start. Okay, there are 2 places on your unit circle where cosine equals 1/2. Where does cosine equal 1/2?
Pi over 3, 5 pi over 3.
Pi over 3, 5 pi over 3. And even though we're not going to need it in our final answer, it's going to give us extra solutions with these. So we're going to say plus the period times k. So plus 2 pi k, plus 2 pi k. All right, so I solved for theta. Now go back and solve for x. So we're going to put 3x in. 3x equals pi over 3 plus 2 pi k. 3x equals 5 pi over 3 plus 2 pi k. And in both of those, how do I solve for x? What could I multiply through to get x alone? 1/3. So pi over 9 plus 2 pi over 3k. And 5 pi over 9 plus 2 pi over 3k. Now, one thing that you can do right now, because I know I'm going to have to be adding on things and I'm going to need common denominators, you can always take that 2/3 and you can just right now rewrite it with a common denominator. Okay, common denominator is 9 here, so I could think of it as 6 pi over 9 if I want to for both of those, and that'll make the next step easier if you want to rewrite it. Okay. So answers that are between 0 and 2 pi. So if I have ninths, 18 ninths is 2. Okay, so that's my limit. If I go over 18 ninths, I just stop and I go to the next set of answers. So my first answer is 1/9 pi over 9. And then just keep adding 6 ninths until we get over that 18 limit that we have. Okay, so 7 ninths, 13 ninths, and then after that I'm at 19 ninths. That's bigger than 2. No more solutions from that piece. Okay, then the next one is 5 pi over 9, and again just keep adding 6 ninths. So 11 ninths, 17 ninths, and if I add another one on, I'll be past my limit. So we've got 6 answers on that. Okay. Yeah.
If there's no like range of like the answers,
It's the same instructions as the other page. I just didn't copy them over. So this one was 0 to 2 pi. Yeah.
But if there was no range.
But if there wasn't, I would actually just stop here and I would say k is an integer, and those would be all of my answers. Okay. Good on those? All right. Let's try a couple that have half angles. Okay, so tangent of x over 2 equals rad 3 over 3. Same procedure. We're going to make it a theta first, solve for the easier angle, and then put back in the angle we started with. All right, so I'm going to solve tangent theta equals rad 3 over 3. What 2 places on your unit circle, tangent's positive in 1 and 3, so that's where we're looking, is tangent rad 3 over 3. So tangent is y over x. I've got to figure out how I do a y divided by an x and get rad 3 over 3.
1 7 pi over 6.
Pi over 6. Well, let me think. What's my y there? My y is 1/2 and my x is rad 3 over 2. That works. Yep. Pi over 6 is the first one. And what was the other one? That you said?
Pi over 6.
Yep, that's right. Okay. And then I need to add on to that the period times k. Now this time it's a tangent, so what period do I add on? Pi k plus pi k. All right, substitute back in my original angle. X over 2 equals pi over 6 plus pi k. X over 2 equals 7 pi over 6 plus pi k. And in both of those, how do I solve for x? Multiply by 2. So x equals, if I do 2 times pi over 6, I get 2 6, or just pi over 3, plus 2 pi k. And then 7 6 times 2 would be 14 pi over 6, plus 2 pi k. All right, so if it said all solutions, these are my answers. Because I, again, want answers between 0 and 2 pi, we start listing. Pi over 3 is definitely between 0 and 2 pi. If you add 2 pi to something, are you still between 0 and 2 pi? No. Okay, so that's the only answer I'm going to get from that one. Now, 14/6, is that between 0 and 2 pi? It is not, okay? If I add 2 pi, of course, it's going to be bigger. Remember, k is an integer, though. It could be a negative number. You could take away 2 pi. If I do 14/6 and I take away 2 pi, what am I going to be left with?
-2 pi.
No. What's the common denominator there? It's going to be 12/6, right? So think of this plus like a plus or minus, okay? Because k is an integer, k could be positive, k could be negative. If I take 14/6 and I subtract 12/6, I get 2/6 or 1/3, which we already have. Okay, so sometimes you'll get a different answer. In this case, we just got the same answer twice, so actually this is the only solution. It's possible with these that you will get no solutions. It's possible that every single answer you get is going to be outside of this range 0 to 2 pi. So it might have an infinite number of solutions, but nothing in that specific interval, and that's okay. All right, you guys try the next one real quick. I'll give you a minute. Okay, let's check them. What'd you get? No solution. Ooh, there it goes. That's it. So 8/3, 10/3, they're bigger than 2 pi. Even if I subtract that 4 pi k from them, it's going to put me into the negative, so it's not going to place any numbers between 0 and 2 pi. That's the one I kind of warned you about, okay? Again, could be lots of answers or actually an infinite number of answers, but nothing in that interval. Any questions? If we've got an angle divided by something.
So if it's like in the negative and it's like asking between our ranges, it's not.
Yep, I mean, not in this class, but in other classes, like you could ask for answers in the interval like -4 pi to -2 pi or something. I mean, negative answers are possible. We're just not asking for ones in that range. Okay. All right. Let's try this problem. Okay, find all solutions. This time we are in degrees now, between 0 and 360. Okay. Replace it with an easier angle. Cotangent theta equals 1. There are 2 places where that happens. Where does cotangent equal 1 in quadrant 1? In degrees. 45 is what we're looking for. That's where you've got the rad 2/2's divided by each other. And then there's one more in quadrant 3. 225 is the other one. And to each of those, I'm going to add the period times k. What's the period of tangent and cotangent if you're in degrees? 180 k. Doesn't it feel weird to do things in degrees now? I feel like it's almost harder. Okay, and then replace the theta with the 3x. 45 plus 180k. 3x equals 225 plus 180k. And then multiply by a third or divide by 3, however you want to think about it. We're going to get 15 plus 60k. And this guy's going to be 75 plus 60k. Okay, and again, all solutions, that's it. We want solutions between 0 and 360. So let's start listing them. What's my first answer between 0 and 360? 15. And then if I add 60 to that, I get 75. And if I add 60 to that, I get 135. If I add 60 to that, 195, 255, 315. And then after that, it's going to be too big. Okay, and that all comes from that first group. And you'll see, we kind of talked about this in the last chapter, when we list both options for tangent and cotangent, this is where you're going to get redundant answers. Okay, that 75 plus 60k is all these same answers over again. We only have to list them once. Okay? Good on that? All right, let's do one more with degrees. Find all solutions between 0 and 360 for the following equation. Okay, so making an easier angle to start. So 4 sine theta equals 1. Okay, this one's a little different because it's not just sine 2x equals. There's a 4 in front there, so we got to think back to what we did in the last section. We got to get rid of that 4 first. Sine theta equals 1/4. Is it possible for sine to equal 1/4? Yes, it's possible. Is it on my unit circle? No, and I know it's possible because it's between -1 and 1, but not on my unit circle. So if it's not on my unit circle, what do we use to solve for the angle? Inverse, we need a calculator. Yeah, so grab a calculator. We're in degrees, degree mode. Remember, the calculator is only going to give us one of 2 answers. So we're going to use the triangles. We'll review from the last section to get that second answer. All right, so I'm getting in the right mode here. I'm in degree mode. Okay, inverse sine of 1/4. Let's just round to the nearest tenth of a degree. It's 14.5 degrees is the first answer, plus 360k. Right. So what 2 quadrants could sine equal 1/4 in? What 2 quadrants is sine positive in? 1 and 2. Okay, so we have the 1 and 1 already, 14.5. We want the 1 in quadrant 2 is the other place. And again, they have the same reference angle. So your job to get that second answer is to find that angle in standard form, what rotates from the positive side of the x-axis all the way to that hypotenuse in quadrant 2. How do I get that angle? What calculation do I have to do?
180 minus.
Yep. And that's going to give me that second answer. 180 minus 14.5 gives me 165.5 plus 360k. All right, put the 2x back in. 2x equals 14.5 plus 360k. 2x equals 165.5 plus 360k. And in each of those, I need to divide by 2 or multiply by 1/2 to get the x alone. So it's going to give me 7.25 plus 180k. And the other one is 82.75 plus 180k. Math Excel might just tell you to round to the nearest degree or something like that. We'll just stick with what we've got here. Okay, answers. 7.25 plus 180 is 187.25 plus 180 would be too big. My next answer is 82.75 plus 180 would be 262.75 plus 180 would be too big. Okay, and you can always double check, make sure you subtract. You're not going to get any extra answers, but usually it goes the other way. Questions there? Okay, you guys try this one. I'll give you a minute. And this, I think that's where we're going to end today. There's just 4 more problems, and we'll do those tomorrow. Okay, so this will be our last problem for today. Is that okay with you, Joe? You seem a little upset about that.
Oh.
I'm tired, Joe. I'm with you. That's good. 120 was the only answer I got on that one. Okay. All right, so let me know if you have questions, and you can take your photos. And I have your 3rd mini quiz I'm going to pass back to you. The rest of the period is yours. You guys can work on either Math Excel. 6.5 Math Excel is due on Friday, and 6.6 is due on Monday. So you want to try to get a few done each day if you can. All right, any questions on this one?
6 is due Monday.
6.6 is due Monday night. Yep. All right. We've got some more time. There's that last little mini quiz you guys can keep. Yeah.
I really said in yours, there's cosecant, there's negative secant.
So change it to a cosine first. So like if it's,
Yeah, okay, so right now that's 6.8 over 1. So you can make it a cosine, make it 1 over 6.8.